Excellent. Really appreciate everybody taking some time to hang out with us today. This is our regular demo day. We sort of use this as an opportunity to, talk about, show off different parts of Decodable and sort of how we can do different things with Decodable, but also really just talk about stream processing, Apache Flink, Kafka, and sort of like the surrounding ecosystem. Based on questions that you have or topics that are interesting to all of you. Obviously, this is a pretty informal gathering of folks, so feel free to jump in with questions if you have them. We're always excited to get into more detail on these things. With that, I am going to share my screen, and today we're going to focus on and talk a little bit about connectors and connectivity, to all of the different pieces of data infrastructure that most people have inside of their internal data platforms, ecosystem services. If you've never seen Decodable before, I'm going to blow up my screen here a little bit. Generally, everything we do is in the context of either pipelines, streams, or connections. And so connections are where we bridge to the outside world and are typically, connecting to things like S3 or Kafka, REST APIs, those kinds of things. And connections come in either a source form or a sync form. So sources for us are places where Decodable receives data from. So they're typically, our source is something else's sync. So somebody might be writing to a Kafka topic. If you want to bring that data into Decodable, that will show up as a source. Similarly, as data leaves Decodable, goes back out to your data infrastructure, like an S3 destination or another Kafka topic or Kinesis, something like that. That's what you'll see here referred to as a sync. And so the goal with all of this is to be able to connect to source systems, destination systems, and then pipelines process data in between those sources and syncs. And those pipelines are expressed in plain SQL. We try as much as possible to make it really, really easy to build those kinds of pipelines. I'll show you some examples in a bit. You can do all the normal stuff that you would expect to do, including nothing at all. So sometimes you just want to move data from a source to a sync. That's cool. We can help you do that. Basically the equivalent of select star from A, insert into B. But you can just as easily do parsing and extraction and transformation, field renaming, normalization, enrichment, all the kinds of like normal things that you would expect to be able to do. And again, I'll show you some examples that we actually use internally here at Decodable. So what you're looking at is what we call, some of us call sort of like the dog food account, where we sort of eat our own dog food. So this is where we are using Decodable to collect information about the service, specifically about the pipelines that are being run by customers. And it's really simple information. It's really just the number of tasks that are running is one of the things that we collect for billing purposes. And so we collect data from a bunch of internally, some inside baseball. Decodable has a number of cells. Customers are assigned to a cell. And this creates unit of observability and security and multi-tenant management and like those kinds of things. So here you can see we have source connections coming from cells 1, 3, and 4 from Kafka topics that other parts of the Decodable platform internally are producing data to. And that is basically these pulse events that say, this is the number of jobs that are running by account and the number of tasks per pipeline or per connection. And that data for us goes to S3, it goes to Stripe for billing, it goes to, some of our own internal observability infrastructure so that we can kind of keep tabs on whether or not the system's healthy and like these kinds of things. This is just one example. You can also see we have the built-in data generator here that everybody gets when they create a Decodable account, but that's stopped. That's not actively running. Connections inside of Decodable, both sources and sinks, are active, which is that they have a target state that a customer says, I want this to be running or stopped, and then it has an actual state. So sort of like Kubernetes deployments or pods, you say, I want this connection to be running, and then the actual state will work its way towards a running state. So the actual state, for whatever reason, maybe it's got bad authentication credentials or something that can actually fail, those kinds of things. Some of those are recoverable. Some of those are not recoverable. So like if we have a temporary connectivity issue, like connecting to your Kafka broker, for instance, we'll go into effectively like a retry state. On the other hand, if you give us bad credentials or a broker that doesn't exist, we're never going to be able to do anything with that. So we'll try a couple times, and if it doesn't resolve within a certain period of time, we'll actually fail that connection, and tell you about it. Of course, so like in that case, your actual state would actually be shown as failed or restarting. There's a couple of different sort of states for things. And so you can see, we can deactivate things, we can delete things. You can't delete something that's running. So you need to, we'll protect you against, accidental deletion by sort of forcing you to stop an active connection or pipeline before you can delete it. Just to show you a little bit. And so I'm actually going to take you through this use case of like getting data from Kafka in real time, processing it with a pipeline, and then sending it out to S3. And in this case, I'll show you what we do internally, which is to partition that data in S3 for analytics with AWS Athena, which is Presto or Trino under the hood, for us to query. It has some sensitive data in it, so I'm not actually going to query it, but I will show you the layout of the files and what that stuff looks like inside of S3. And I'll show you writing that data in Parquet, Apache Parquet format, which is a columnar format that's sort of optimized for analytics. Obviously, you have a couple of different options there. So just looking at this one connection, I'm just going to sort of like pick one. So cell 1, for instance, there's actually more cells that aren't listed here, but I won't get into the details. That's more about sort of how Decodable works internally. So cell 1 here, this is a connection that we've named usage metrics cell 1. You can see it's a source connection. It's connected to Kafka. And so each connection uses a different connector under the hood that have different configuration properties. There's some stuff that they have in common. There's some stuff that's special to each one of those connectors. But every connection has, this overview information. It has a schema, which we can talk a little bit more about. And it has, effectively connection details or those properties. And I'm showing you the UI. There's all of this information is also available via the command line interface. So if we take the connection ID, we can actually pop over to the command line and we can actually get, whoops. Oh, I'm in the wrong account. So the CLI is logged into a specific account. So like you can equally get connection information that gives you sort of a nice text output from the command line if that fits your use case better. Of course, you can also use our APIs for everything I'm going to show you. We're actually just using our own public APIs for these things. So anything we can do from the CLI or from the UI, you can do too via, CI/CD pipelines and application infrastructure and those kinds of things. So in the case of Kafka, when we can create these connections, there's some Kafka specific configuration that happens, like the value format of the, how do we want to deserialize or serialize the events that are in the value field of the Kafka event. The Bootstrap brokers, and this is a little bit hard to read, but it is a comma separated list of Kafka brokers. You can see we're actually using AWS MSK for Kafka inside of Decodable. And these are hostname port pairs. So this is basically the same information that you have if you use Kafka separated by a colon. Can't include any spaces. And then a connection is to a specific topic. And there are reasons why we do this. Behind the scenes, we can actually share connection information and those kinds of things in certain cases, but we specifically want to enable people to very easily map one topic to one schema. And that schema can be semi-structured, it can be fully structured. There's lots of different ways you can sort of interpret that. I'll get more into that in a little bit. But in this case, we're reading from job state cell 1 on these brokers, and we're using SASL SSL as the broker protocol. You see, we support all the normal stuff that Kafka supports, plain text, which you should never use, TLS, where broker side is effectively authenticated by by the client, a mutual TLS where both sides are authenticated, and then the SASL SSL and SASL plain text protocols that some of these vendors support. And even within this, there's different mechanisms within SASL SSL, like plain, Scram 256 and 512, SHA values, username and password. And some of this information that you're seeing here is stored in underlying secret stores. So we don't store sort of passwords and things like that in plain text. Those are under the hood inside of Decodable. Some of these properties go to secret stores. Some of them are stored in our own sort of catalog database of connection definitions and information. The other important thing is that, so this tells us that data is coming in over this topic. It's coming in JSON format in the value. This schema is what tells us what fields exist or must exist inside of that JSON payload. And because we're sort of SQL centric and we're banking on people's pre-existing SQL knowledge, we use the same data types. It's sort of an enhanced set of data types for SQL. So string is synonymous with text, which is basically a varchar to, a varchar that is, of a particular max size, but variable length. Integers, strings. We also support things like nested data structure. So we use the term row to represent like a nested record, basically. So this usage metrics is a row that contains a num tasks int field. If you envision the JSON blob, this is a usage metrics object field that has information in it. And there's obviously a full set of reference information. There's lots of stuff you can do with schemas. I won't go into all the details here. And then finally, once the connection is running, so we can stop it, we can start it, we can edit, things like, connection information and description. You can see that this connection is connected to one output stream, and I'll show you that in a sec. It's running, and so we actually see metrics in real time. If you watch closely, you can see these things tick. This is a very low volume connection because it's really just like metadata pulse information about aggregate statistics on usage. Doesn't actually contain a lot of data. But it's just super convenient for us to do this. And so you see like bytes per second, records per second, total bytes, total records, and you will get that information on every connection. So that's independent of Kafka. So we know how to source this from a bunch of different places. This connection is attached to this stream. So, and the stream under the hood is effectively a Kafka topic. It has all the same properties as a Kafka topic. So this is how we handle things like if the pipeline gets restarted, we won't lose data because the connection is producing into the stream. If there's, on the sync side, if the downstream system is unavailable for some reason, the pipeline can continue to process data and it will simply queue up in its output stream. And again, I'll show you more of that in a little bit. And so this stream has the same schema as the connection because that's what it contains. The reason we decouple these things, and I think it's super important to talk about this, is that in a lot of cases, people have, you can think of stream as like a table in a database. You might have multiple sources that all produce to that stream, or on the sync side, multiple connections that read from that stream, or multiple pipelines that read from that stream. And so this, by separating it, it does add a little bit of complexity. It's like one extra thing to worry about and to configure. That said, we automatically can create the stream from the connection. So we try and make that as easy as possible for you. But it does give you a whole lot of flexibility for like fan in and fan out data architectures, which are super, super common and critical in these kinds of systems. So this is the stream, and you see that it has a name. Here, there's no metrics because streams are passive. Connections write to them, pipelines can write to them, and then connections and pipelines can read from them. Those are the active components. So the stream itself doesn't have like a records per second or anything like that, because that's actually a function of the connections and the pipelines that are reading to it or writing from it, writing to it or reading from it. And so really, there's very little configuration here. Really, it's a name, a schema, and like I said, there's lots of details. You can read about schemas in our docs that will teach you all about sort of the different data types that are supported and all the different ways that you can configure them. Watermarking to deal with late arriving data. There's all sorts of like details here. And then I'll show you the output side as well. So we have, before I get into the pipelines. So here we have an S3 output, and S3 is like one of the most common. The place where people use Decodable quite a bit is between like basically like data processing middleware between Kafka topics. And we don't view ourselves as a replacement for Kafka brokers and things like that. So people can use us with people like Confluent or AWS MSK or RedPanda or sort of like any of those kinds of things. We obviously support other connectors than Kafka. We support Kinesis and a couple of other things as well. But just to give you sort of an idea of what that looks like. On the S3 side, again, you have the same sort of overview metrics. You have, in this case, the schema of the data that's going to be laid out in S3. And so this would match your table definitions with like Presto or Trino, or in our case, Athena. It can be used to match schemas with like Snowflake data loads or RedShift, and all sorts of other things that work with S3. The connection details here are S3 specific, which kind of makes sense. And again, we're going to ask you like, how do you want to serialize that data inside of S3? And we support Apache Parquet, we support JSON, new line delimited JSON records, and raw, which is kind of poorly named. That's bad on us. I think it's just UTF-8, new line separated records. I see Tim on the call. Tim, keep me honest. Is that raw is new line separated records?
That's right. It's really just however the bytes come in is how they land on in S3. But new line with new lines between.
Right. Tim is one of our founding engineers. He actually wrote the S3 connector, so he's always good to keep handy. Keep me honest. The rest of this stuff is the stuff that you would normally see with S3. So the region, the S3 bucket, the directory. In this case, it's sort of like an S3 prefix, and the IAM role ARN. So we exclusively use role-based authentication to S3 because we believe that it is the correct way and the most secure way to operate with customer S3 buckets. And we use external ID auth. I think we're going to produce a blog post and go into more detail on sort of the details of external ID auth and stuff like that. Tim, is that right?
That is right. I mean, the external ID auth is the official solution from Amazon for this. They have a great paper about it called the Confused Deputy Problem, about what the security issue is that this solves and how it solves it. It's worth internalizing that, but we certainly just provide instructions on how to get this done in a way that where security is taken care of for you.
Yeah. So the short version is, you configure this this IAM policy, and then we will assume a role that you can authenticate. And there's effectively, mutual sort of, trust here in that, we will assume this role, and then you have to allow us to assume that role. And there's this additional check, which is the external ID part, that basically ensures that we're not going to do that not arbitrary people can assume this role and sort of write to this. So there's sort of a bi-directional trust thing that happens here.
That's right. Like Decodable will only access your S3 bucket in terms of your Decodable account. So no one else's Decodable account can access your S3 bucket while maintaining no secrets in this security regime. So there's nothing to compromise.
Right. And so we're piggybacking on sort of all the pre-existing audited, sort of known good and secure infrastructure that Amazon provides here. Finally, the important stuff, I think, for things like Presto or Databricks or whatever you're using to sort of access this data in S3, presumably for analytics, that's usually the reason people write the stuff to S3, is sort of the partition structure of how data gets laid out within that S3 bucket. And so we support like the typical templating system. And again, there's docs here on sort of all the different ways that you can template this so that it works with Apache Hive or Presto compatible partitioning structures. And we support a whole bunch of different options on, wow, Tim, you did a great job on the docs. All different ways you can sort of partition and lay out that data inside of S3, including some examples, to do value-based partitioning.
Just to jump in on that real quick,
yeah.
One of the most important ways that people use partitioning is to partition timestamps broken down by calendar parts. It's a thing that solves most of the use cases that we see. So we provide a very rich way of handling that so it can be tailored to your use case. It depends a lot on data rates over time, how you want to do that partitioning. But we make that available.
Yeah, good call. So this TS, abbreviation, so basically for something that is a SQL data timestamp, TS winds up, the shorthand for this winds up being partitioned where by year, by month, and by day. And Decodable always operates, based on the value inside of that field. So in this case, our timestamp field is going to be called TS, and because it's a timestamp, the formatter will actually lay it out like this unless we tell it otherwise. And there's all sorts of different options to get it to lay out, on disk in different ways. So you can see that our data is going to be partitioned by cell ID, by account ID, and then by time. So this allows us to lay out data for relatively fast reporting by account, by cell, and by time. And finally, we use snappy compression for Parquet. We give you a bunch of different ways of compressing that data if you're using it. And the UI has like lots of nice controls where, if you were to select things like JSON, we're going to give you, a different set of options, and that makes sense there. So we'll just discard this because I don't want to mess anything up. And again, so this is sort of our output schema. And then finally, the thing that sort of stitches all of this together, I should say, this S3 bucket, just to remind you, is inbound from one stream, just like the source side. This stream is, has a concrete schema, effectively feels like a table, but operates like a distributed message queue. And then we have these three pipelines, one per cell, because it's what makes sense for our use cases. And these, similar to the connections, are up and running. They have input metrics and output metrics because they're connecting basically streams. So pipelines always and forever operate on streams. So in this case, we always use this select into, select insert into select syntax, because it's stock SQL and people are generally familiar with it. This is similar to, but has slightly different nuance differences with like create table as select. In this case, insert into select is the appropriate SQL for our case. And basically what you can see is we're just reading, we're not doing any filtering, there's no where clause, there's no aggregation here. We're actually just taking this data from the raw stream and we're renaming some fields, really simple stuff. We're just doing like static enrichment of plugging in the cell ID because we know that this is the pipeline for cell 1 because it happens to not be in the source event. Again, more renaming. We know that this is only sort of handling num tasks as the metric name, and then we're coalescing and basically, dealing with the case where, the number of tasks simply might not be present, and handling that case and inserting zeros. Finally, we convert the timestamp and rename it. So some of these things you can see are quoted because they're reserved keywords in SQL itself, or contain things like dashes, in our case. And we're converting this in timestamp local time zone. In this case, the system runs in UTC, so we know that that's safe. And then this pipeline is up and running. You can see this is both the latest version of the pipeline and the active version of the pipeline. And that's it, really, really simple pipeline. In fact, I can run a preview here, which will latch on to this input topic and start to show me a sample of the data as it ticks through the system. Again, this is a low volume pipeline. Preview in Decodable will only show you the 10 records or 2 minutes worth of data, whichever comes first. And you can see here that, basically it's doing the thing that you expect it to do. We sort of know that our query, our SQL statement is doing the right thing. So you see different job IDs, see different account IDs. This is, like I said, how we calculate sort of like internally the number of tasks, pipelines and stuff like that are running, for billing purposes and for certain analytics cases. And so eventually this will stop running because it reaches its 10 events or its 2 minutes. This pipeline's running, so you can also see that it's just ticking at about 1 record per second, 65,000 records, on the input side, 65,000 records on the output side. And you'll see occasionally, because these metrics are eventually consistent, most of the time this will match, but occasionally one will tick up, faster than the other one. This will also be true if there's some kind of issue with the pipeline or there's back pressure. So you can sort of detect a whole host of random cases. And just to sort of prove that things are, working as advertised, if you remember correctly from our output, we're writing to the super awesome usage metrics dog food directory inside of the Decodable product usage S3 bucket. So I'm just using the Amazon command line tools. If I list this, you can see that we have some uncommitted files. We have, prefixes for different cells where the data is being laid out. And this is probably going to just spam my screen with file names, but you can see that, we have just a ton of Parquet files that are being written. There are lots of controls that are not yet available in the UI about the way these connections are configured and stuff like that. So at the UI, where we had built a whole bunch of functionality, we're now sort of getting the UI to catch up a little bit. And building sort of nice UIs on top of things like you see here with the S3, or sort of guide people to do the right thing. So there's some more advanced options that aren't fully available yet. UI, we'll sort of get there over time. We're actually actively working on closing that gap today. But there's all sorts of things that you can do to control different elements of the connections, including things like parallelism and those kinds of things. So these are low volume. They're running with a small number of tasks. So when we look at these connections, you can actually see, this is an older version of the CLI, so it doesn't have it, but there's a concurrent number of tasks that you specify on pipelines and on connections that decide the parallelism factor. And in fact, it's the maximum parallelism factor. There are cases where if we know, if the query engine understands that it can't fully take advantage of the parallelism for whatever reason, it will actually contract to use the smallest number of tasks possible. And our pricing model is based on active number of tasks. I'm not here to sort of convince you to buy Decodable today, more sort of just like talk about sort of how things work. You can find out pricing information on our site. It's basically 20 cents per task per hour. But you can decide sort of like if you have a higher volume pipeline, how much you really want to spend on that. And we'll tell you, for instance, what throughput you're seeing on that. You can decide to scale it up or scale it down based on, what makes sense for you. We will be exposing things like auto scaling of pipelines. And we do some of the stuff, like I said, like the query planner will decide to contract in certain cases, but we want to be able to dynamically handle sort of load over time. And so we're working on introducing auto scaling of the number of tasks. Again, you would set a maximum, and then we'll scale up to your maximum based on periodic, sort of changes in volume of data. And we'll also scale down so that we don't, overspend in cases where that CPU could actually be released. We talked about Kafka and S3. But like I said, there's a number of different connectors that we support both on the source side and the sync side. And one of the things I want to point out here is that we have very purposely not introduced proprietary APIs and those kinds of things for for connector connectivity. I mean, we have a REST API where if you're building like a JavaScript application, you don't want to deal with things like Kafka and Kinesis, you can just pump event data at us and we'll do the right thing. On the other hand, it's so common that people have Kafka, Kinesis, all these kinds of pre-existing systems, and lots of infrastructure that already knows about like the Kafka ecosystem or the Kinesis ecosystem. We want you to be able to take advantage of that stuff. So there's no proprietary payload formats or, those kinds of things. So if you're using Avro or JSON or, whatever, makes sense in the serialization of these kinds of things, we support things like the, Kafka schema registry, or maybe it's the Confluent schema registry. Either way, we support the schema registry with Avro, define schemas and stuff like that. And there's actually a really nice workflow around, attaching to, that schema and stuff like that. The nice upside of this is that anytime, like if you actually have some really sort of bespoke or sort of weird system that Decodable doesn't support, but there's like a Kafka connector that you've already built for it or something like that, we're happy to receive that kind of data. And so anything, even if we don't have a purpose-built connector for something that you're looking for, if there's like an open source version of that, that totally works with Decodable, and that is by design. Like we're never going to change the way that we handle that. So this gives us access and the ability to work with systems, everything from Redis or pre-built Kafka connectivity with things like, or Kinesis, things like RedShift or Snowflake and Snowpipe and like all of these other kinds of systems. Apache Pinot, our friends over at StarTree, things like Rockset, I think supports Kafka natively. And so all of these kinds of systems that increasingly support Kafka as like a first class, or Kinesis as a first class citizen. And I say Kafka and Kinesis, this also goes for things like Pulsar, RedPanda, all sorts of other messaging systems. Are sort of immediately useful. You can get started right away in building pipelines between those things.
I want to point out something about our use case here. Can you go to the SQL on this pipeline,
Sure.
please? Right. So as you see, this SQL is specific to our cell one. Now, cells are an organizing principle of our own infrastructure, in which infrastructural resources are built, most of which are in AWS, but some of which are in some other services like Auth0, and now in our own service, Decodable. So as we expand our infrastructure and the patterns of our infrastructure, it's very natural and easy to include decodable resources, pipelines, connectors that are really specialized to our other infrastructure resources in a way that doesn't require us to do the tremendous lift of building up a bunch of lower level streaming ourselves. We've already managed that in an abstract way. So this is already a huge potentiator just for us. That may not be obvious. This is not like handwritten SQL in each one of these pieces. It's auto-generated.
Right. Good point. This the CLI is basically just like a bunch of like developer productivity stuff wrapped around our APIs. Under the hood, it's implemented in Go. So really all it's doing is managing, some authentication and authorization stuff, and then making a bunch of API calls. So you can see like everything I showed you via the UI, you can do from CLI, including things like, all the operations on connections like activate, create, deactivate, so on and so forth. And for the cases, for things like pipelines, for instance, I can even preview, with this SQL statement, select star from, I think this stream has data flowing through it in this account. And so this will basically do the same thing that the UI does. It'll sort of like fire up, it'll connect to a stream, sort of, run the query in an ad hoc fashion against the pipe. And like I said, all the APIs that we have, I don't know if there's actually anything coming through the stream. Oh, there is. So this is some fictitious Envoy data that's being parsed out, where we can do all sorts of stuff here. So, we can even say, I think methods a reserved word, method, in get put. Let's see if we have anything sort of matches that. So we actually use this stuff pretty heavily internally just to just to sort of like test and demo and sort of like, even for our own sort of analytical use cases and stuff like that.